In this video, we're going to continue with the addition of vectors and mainly with the parallelogram rule. Now, what is the parallelogram rule and when do we use it? If we have the sum of two vectors from the same origin, so we have AB is a vector and AC is a vector and they both have the same origin, which is A. So we complete constructing a parallelogram and the resulting vector will be the diagonal of the parallelogram from that origin. So AB plus AC is equal to AD such that AD is the diagonal of the parallelogram. Here is an example from real life, aviation and wind speed. If we have a plane that is flying at 400 kilometers per hour due north, and we have the wind speed is 50 kilometers per hour, and it is blowing at a 45-degree angle from the east. So, if the plane is going north and the wind is blowing at a 45-degree from the east, then the resulting direction of the plane will be the diagonal of the parallelogram when we completed from the starting point. The 400 kilometers per hour is represented by the length of the vector, and the 50 kilometers per hour is represented by the length of this vector. So the resulting vector is, or the resulting velocity is the velocity of the plane plus the velocity of the wind. Here's another example on vector addition. We have a rectangle ABCD with center O, and we have to draw OI perpendicular to AB and OJ perpendicular to BC at I and J respectively. The first question, we have to prove that OIBJ is a rectangle. First, we have this is a right angle at I, and we have another right angle at J because of perpendicular lines, definition of perpendicular lines. And since ABCD is a rectangle, and we know that all the angles of a rectangle are right, then angle IBJ is right. So we have three right angles, and a quadrilateral with three right angles is a rectangle. Therefore, OIBJ is a rectangle. The second question is, we need to prove that vector OI plus vector OJ minus vector DB is equal to vector OD. First of all, in vector addition, every time we find a minus, we have to turn it into a plus. We know that the opposite of the opposite is the number itself. So, when we put a plus here, we take the opposite of vector DB, which is vector BD. So, changing it to plus vector BD will give me the opposite of the opposite, which is the vector itself. We insert parentheses here. OI plus OJ, if we go back to the figure, OI plus OJ are two vectors from the same origin. So the answer is the diagonal of the parallelogram from that origin. And since any rectangle is a parallelogram, so OI plus OJ will give me OB. Plus BD, if I look here, the extremity here is B, the origin here is B. So, using Chisel's rule, the answer will be the origin of the first with the extremity of the last, so it is vector OD. So, I have proven this part. The other part, I need to prove that OI minus OA is equal to IB. So, I have to change minus OI to plus AO. Here, I rearrange it. AO plus OI will give me Chisel's rule AI, but AI equal IB since I is the midpoint of A